In 2010, the Journal of Clinical Oncology published a study that the National Cancer Institute still cites today as proof that the Gonzalez Protocol, an enzyme-based nutritional approach to treating cancer, simply doesn't work. The headline numbers were devastating. 14 months average survival for patients on standard chemotherapy, 4.3 months for patients on the Gonzalez Protocol. Except, according to my guest today, that study never actually tested the Gonzalez Protocol. The patients assigned to the enzyme arm were largely too sick to follow it. Many never started it at all, and the federal agencies charged with overseeing clinical research later found that the trial's principal investigator had violated very basic rules of patient consent. The NIH's own representative acknowledged in writing, while the study was still running, that, well, and I'm quoting directly, it is very difficult, if not impossible, to ascertain treatment effect with certainty. Well, none of that made it into the published paper. Today, I'm sitting down with Dr. Colin Ross, a psychiatrist and researcher who has spent years publishing peer-reviewed work on both the science behind the Gonzalez Protocol and the methodological failures of this trial. Dr. Ross, welcome to Your Way Back. Most of our listeners know this is a show that is a space for exploring the Gonzalez Protocol and what Dr. Nicholas Gonzalez's work offers patients. But you, Dr. Ross, come at this from a different angle. You're a psychiatrist. You run an institute for psychological trauma. How did you end up deep in the science of a pancreatic cancer clinical trial?
Well, it was basically by accident. So I had a friend who had a kind of pre-cancer problem, not actual cancer, and over visiting and hands me this book. Says, "Oh, you might find this book interesting. Trophoblast model of cancer. I wonder what that's all about." And so oh, what a coincidence, you have a copy. And so just literally read the first couple pages and said to myself, this is amazing. This is like completely scientific, logical, testable, makes sense. I'm going to read the rest of the book. And then, which I did, and then read some other materials. And then March, I think it was 2015, before that, I actually wrote a paper about the trophoblast model. And I thought, it would make sense if I send it to Dr. Gonzalez to get comments from him. So I did that, and he was quite blown away that anybody had written a paper about it. And then in March 2015, I was in New York for a conference, and I visited him, had lunch with him. And that's how I got into the whole thing.
Dr. Ross, before we get into the trial, I want to make sure listeners understand what we're actually talking about. Can you please give us a plain language description of the Gonzalez Protocol, what it is, what it isn't, and what the theory behind it says about cancer?
Sure, be happy to. So the protocol, which was named after Dr. Gonzalez, was developed based on prior work going back to the 19th century. And the basic idea, so I'll describe the foundations of the protocol and then the protocol itself a bit. This John Beard was his name. He was actually nominated for a Nobel Prize for related work. A Scottish embryologist, this amazingly detailed collection of slides, thousands of slides of embryos of different species at different stages of development. And he noticed that he wasn't a cancer guy at all, wasn't thinking about cancer. He noticed that the trophoblast, which is the precursor of the placenta, which is made of trophoblast cells, it stabilized and became the stable placenta at the same time as the pancreas started secreting pancreatic enzymes. So I thought, I wonder if the pancreatic enzymes are the signal that tells the trophoblast cells to settle down. Because what they do, what their job is they have to invade the wall of the uterus, They have to create their own blood supply. They have to resist surveillance by the mother's immune system. They have to be able to migrate, change locations, and they're relatively undifferentiated. They're sort of primitive. Exactly the characteristics of cancer cells. So we went, oh, so trophoblasts have to be like a cancer that invades the mother's uterus in order for baby to grow. But something has to settle it down into a stable placenta, equals pancreatic enzymes. And if that doesn't happen, if the trophoblast just keeps eating away, it becomes choriocarcinoma and kills the mother. So then next step was he went, oh, well, I wonder what would happen then if we gave pancreatic enzymes to people with cancer? Would the enzymes quieten down the cancer cells and make it be just a benign piece of the body? So that's how we got into the model. It wasn't just random. It wasn't like goofy outside science. And in sort of 1895 to 2010 timeframe, The Enzyme Treatment of Cancer is a book that he actually wrote about all this. There were some people around the world, mainstream regular people, treating cancer with pancreatic enzymes. And in the book, there's a photograph of a guy with a big cancer on his cheek. It just fell off, and he lived a normal life. But then, for a variety of reasons, there's trouble with the supply of the enzymes. They weren't quite properly prepared, fashion, who knows what other reasons. It just disappeared. And then there's another guy who picked it up a bit in the 1930s, but there was, funnily enough, a periodontist in Fort Worth, Texas, Donald Kelly, who read about it, treated his own cancer with pancreatic enzymes, and then started treating a whole bunch of other people. And Dr. Gonzalez heard about this when he was medical student/intern, and talked to his supervisor, Dr. Good, who was a top guy in immunology, and said he'd like to go spend a little time with this Donald Kelly guy and review all his files and see if there's anything to it. And so he saw that there was, and then he kind of took it over, modified it some, and that's the source of the Gonzalez Protocol. And the protocol has basically 3 arms. So the anti-cancer arm is the pancreatic enzymes. There's a dietary arm, supplements, a lot of supplements to support the health of the person. Because what happens when you have cancer, your health goes down the tubes, right? And you add on chemotherapy, your health really implodes. So that's support of the person, not treatment of the cancer as such. But a healthy person, obviously, is going to be able to fight off cancer better. So there's the enzymes, there's the diet, and then there's detoxification. And detoxification isn't attacking the cancer as such. It's when you break a whole bunch of cancer cells in half, so to speak, all the contents spill out into your bloodstream. And this is well recognized in medicine that you can get all kinds of sickness, bad symptoms. It's called tumor lysis syndrome. Lysis means to cut. And pancreatic enzymes are used in Europe just to help with that. And then he had enemas that he prescribed to clean those toxins out of the bloodstream, out of the bile, faster, so you had less trouble with nausea and sickness. But really the core is treatment with pancreatic enzymes.
Dr. Ross, you've published articles on the trophoblast model of cancer. In plain terms, just please explain, what is the trophoblast? What does it have to do with cancer? And why did a Nobel Prize nominated Dr. John Beard, way back in 1902, think that pancreatic enzymes were the key?
Well, obviously, somebody who's been nominated for a Nobel Prize is a for real scientist. So this didn't just come out of some intuition. This is a guy who studied thousands and thousands of slides of embryos in different stages of development. And from observing the fact that the trophoblast, which settles down to become the placenta, transition from the invasive trophoblast that behaves like a cancer, invades the mother's uterus, it has its own blood supply, the cells have to migrate, they resist surveillance by the mother's immune system, and so on. There's got to be some signal that tells the trophoblast to settle down and become the placenta and stop invading the mother. And he noticed that that happens in these different species on the same day that the pancreas starts to secrete pancreatic enzymes. So naturally he went, I wonder if the enzymes are the signal that switches the trophoblast into the placenta. And that's how he got into just a little bit on his own. And then it caught on. And for 15 or so years, end of the 19th century, beginning of the 20th, people around the world were treating cancer with pancreatic enzymes. And so the reasoning was, the properties of pancreatic cells, when they're still in the trophoblast stage, they're the same as the properties of cancer cells. Cancer cells invade, they migrate all over the place, they're undifferentiated, which means that they're not really well formed. They're sort of like primitive stem cells. And therefore, since they have the same properties as the trophoblast cells, maybe the enzymes will settle cancer down. And then the model that comes out of that, he called these cells wayward trophoblasts. About 10% or so of the normal trophoblast cells he saw in his microscope break off and seed all around the body in different tissues. So he called those wayward trophoblasts. And today we call them stem cells. And the model is very different. In most research today in academia, the idea is that there's an abnormal gene, and the abnormal gene causes the cancer through mutations and so on. But his model and the trophoblast model of cancer is, no, these aren't normal cells in, say, the breast or the liver or wherever that de-differentiate backwards to become cancer cells. These are wayward trophoblasts that, for some unknown reason, escape normal regulation in the tissue that they're in, and because of local signals in that tissue, when this is all backed up by solid science, they take on some of the characteristics of the surrounding tissue. So a trophoblast that kind of wakes up and starts misbehaving in breast tissue starts to look a little bit like primitive breast tissue. If it's in muscle, it starts to look like a muscle cell. So the whole model of the formation of cancer is different, and the treatment is lots and lots and lots of pancreatic enzymes, and the cancer is going to settle down and become a stable cell, just like trophoblast becomes placenta. That's the basic model.
Thank you for explaining that so clearly.
Okay, you're welcome. So I've published a series of papers in mainstream medical journals about the trophoblast model, which just illustrates the point that this is not some fringe way out there, quotes, alternative model. It's very mainstream, and I'll get into more details on that as we go along. And the reason I wanted to publish is, first of all, I like publishing, and I think it's extremely important for the accurate information about this model to get out there, and for mainstream researchers and scientists to start taking it seriously.
So, Dr. Ross, you've actually argued that the evidence base for the Gonzalez Protocol is what you call level 2, and that this is a meaningful scientific standard, not a constellation prize. So, can you explain the evidence hierarchy and where the protocol sits within it?
Sure. So this is U.S. Public Health Service mainstream medicine criteria. There's some organizations that have 4 levels, but it's the same setup as the 3 levels, level 1, level 2, level 3. The highest level of evidence, and none of this is debated in the medical literature, everybody agrees, the highest level of medicine is randomized controlled trials. So that's where you bring a lot of people in who have whatever the problem is, and they're randomly assigned to get either the active treatment, a comparison treatment, or placebo. And the people don't know which they're getting, and the doctor doesn't know which they're getting. So it's a pill. Everybody goes to the hospital pharmacy, gets their pill, That's why the doctor doesn't know which one they're actually getting until the study's finished. Then they break the code, and then they analyze and say, oh, people on placebo had this outcome, people on the new drug, this one, people on the comparison drug, that one. And that's really the proof. And for like antidepressants, since I'm a psychiatrist, people do meta-analysis where they group together like 50, 70, 80, 100 of these randomized controlled trials and get the whole tens of thousands of people involved to give the final word. So it's not just this one study or this study or this study, it's dozens of studies. And the same principle applies everywhere in medicine. So problem was, well, we didn't have any control data of any kind, any experimental published evidence that the trophoblast model works. But then a guy you may have heard of named Nicholas Gonzalez and his colleague partner Linda Isaacs published a small study of 11 advanced pancreatic cancer patients on the protocol who did very well. And then that led to applying to the National Cancer Institute to do a big study. But so that's level 1 defined. Level 2 is what's called cohort studies. So there's no control group, there's no placebo group, but you have whatever the problem is, broken leg, ear infection, depression, pancreatic cancer. Everybody has that problem. And then you initiate a treatment and you follow them forward in time. So that's called prospective study because it's going forward in time. So that's called level 2 evidence. And point being, it's not quite as conclusive as level 1, but it is scientific evidence that gets published in mainstream journals. And you pile up all the evidence you've got, and then you see what the picture is. Level 3 is small case series, expert opinions, guidelines by professional associations. And those are all levels of evidence. So the Gonzalez Protocol has got strong level 2 evidence. As you know, we've published, I sort of did help in the background with the editing, 160 cases of cancer treated with the protocol, with all the fantastic, amazing outcomes.
And you've actually published some of those cases in your own papers.
Right, yeah, I published some of them. So mainstream sort of nitpicky guys will go, well, there's no randomized controlled trials. Okay, but let's say you're not invested in chemotherapy, you're not invested in medicine, you're just a sensible person looking at the evidence. What does the evidence show us? People with pancreatic cancer, stage 3, 4, which is where it's spreading around your body, have horrible survival times, like average under a year, months. If you go to any of MD Anderson or any of the main cancer places anywhere in the world, and you talk to the most high-ranking oncologist, how many stage 3, 4 pancreatic cancer cases in your practice ever have survived more than 10 years? None. Like nobody has these kind of cases which Dr. Gonzalez said, where people are alive and well and functioning and happy 10 years after a biopsy confirmed diagnosis. So why would we just ignore that and blow that off and try and discredit that?
It's actually the book that you helped edit.
Right.
That we published after Nick died. And it has a whole host of pancreatic cancer cases.
So if you're just like average, regular, sensible, common sense kind of person, and you hear, wait a minute, this Dr. Gonzalez guy has got many, 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 many stage 3, 4 fatal cancer patients, not just alive, but alive and well a decade later, and survival times way beyond what other oncologists can come anywhere near. Why would we want to suppress that and discredit that and not take it seriously? It's a huge political problem in medicine. And it's not a scientific problem, it's a political problem.
So here we have this century-old scientific model, a Nobel Prize nominated embryologist, over 160 documented cases of remarkable survival in otherwise lethal cancers. And then in 1998, the NCI, National Cancer Institute, approved funding for what should have been a landmark study. Now, as an aside, I met Dr. Gonzalez in the year 2000. So I had a front row seat to this whole experience. But let's hear from you about how that all went. And what I'd like to know is when the NCI announced that it would fund a clinical trial comparing the Gonzalez protocol to chemotherapy for inoperable pancreatic cancer, Dr. Nicholas Gonzalez was initially excited about it. What was the original study design and what was supposed to happen?
Well, what was supposed to happen is obviously Dr. Gonzalez would be heavily involved in the design of the study, conducting it, meetings, discussion, publishing the results. And it was set up initially that the collaborator providing the chemotherapy arm based in Colombia, Dr. Chabot, he would be involved, and it would be like a team partnership. So some people would get assigned to pancreatic enzymes, Gonzalez protocol. Some people would get conventional chemotherapy, and we'd see how it all works out. And so all the criteria for enrolling people and documenting the cancer and so on were set up in advance. And then it started running. And all of a sudden, reality looked very different from the theory of the trial. So in the 14 months, they only enrolled 3 people. So it's going to take 500 years to finish the study, right? And it wasn't that only 3 people applied. 162 people applied to participate in the study.
I think it was 262.
It was a big number, whatever it was. And why was that? Well, it was set up as a randomized controlled trial, like I just described, which in theory is a good idea. But what actually happened was the people who believe in chemotherapy didn't want to be on pancreatic enzymes, and the people who wanted to be on pancreatic enzymes didn't want to be on chemotherapy. So nobody agreed to participate. So what they did is they changed it to a kind of a cohort study where people could choose which arm they wanted to be in. So they would match, okay, this number of people said yes to enzymes, this many people said yes to gemcitabine, which was the chemotherapy, and off we go. So it looked like, okay, we had to modify a little bit, but it's still, the team is working on it together as a team.
And yet in the published paper, you mentioned that only 3 patients enrolled in the first 14 months. Well, it doesn't mention anything in the paper about how that was out of 262 people. Is that an omission that matters scientifically?
It's only one of numerous omissions that matter scientifically. So you're supposed to, the idea is when you publish a paper, you have to describe it in enough detail that another investigator could repeat the study exactly. And so you have to know, well, what was done, what happened, how was it run, how was it organized. And this is crucial information. This is not just a little side thing like what color socks did they have on or something. I mean, this is core important information that there's this huge problem. And then that's only one of many admissions in the paper. So the paper did mention about the first 14 months. It didn't mention the fact that the paper says that there's 32 people who completed the Gonzalez protocol, but it started off as 39 people. So where did those 7 people disappear to? There's no discussion of that. It's not explained. There's a whole bunch of people who there's no record that they ever provided informed consent. That's not discussed.
So, Dr. Ross, after that near total enrollment failure that you just discussed, when the trial switched to a matched cohort design where patients could choose their treatment arm, that sounds like a reasonable fix. I mean, there's a big difference between the types of patients who want to completely change their lifestyle and be actively involved in a compliance-intensive at-home treatment and people who prefer to visit a clinic and get chemotherapy. But the problems didn't stop there, right? Because of who controlled the study going forward. Could you talk a little bit about the power structure of the trial and how it changed and became a conflict of interest right from the start?
Well, the whole thing's pretty outrageous. So you would think that here's the world's expert on the Gonzalez Protocol, Dr. Gonzalez. He's going to be involved in going to meetings, planning things, reviewing charts, discussing what comes up. Completely shut out of all of that. He's completely shut out of patient selection. And Chabot and the people at the medical school are completely in charge of all of that. And they just send them people for pancreatic enzyme treatment. So, besides they didn't all give documented consent, the majority, like the big majority of the people referred to the protocol either didn't even start it at all or dropped out within the first week because they were too sick. They didn't have the social support. They couldn't eat. So in the end, this is so fantastic that you think it never happened. In the end, 1 out of 39 people referred to Dr. Gonzalez actually completed the protocol. So it's so unbelievable that you'd think this couldn't possibly ever happen. But it did happen. And that is, since Dr. Gonzalez had no involvement in screening whatsoever, people just arrived at his office having been assigned by the Columbia team to the enzyme arm of the study. What happened with these people? So 11 out of 39 either dropped out immediately, never started, or dropped out within the first week because they were completely unsuitable. They couldn't eat, they were too sick, there's all kinds of things wrong. In the end, only one person fully completed the Gonzalez Protocol. So, I mean, right there, it's just preposterous, ridiculous. You can't conclude anything. None of that is mentioned in the paper at all. The paper makes it look like 39 somehow became 32, but 32 people did the protocol. But only one person did the protocol fully. And the 2 people who survived the longest out of the whole bunch, chemotherapy and protocol, were both enzyme patients. And of course, that fact that the 2 longest surviving patients were enzyme patients is not mentioned in the paper.
So I remember that Dr. Gonzalez repeatedly asked for there to be a lead-in period before patients were actually enrolled into the enzyme arm. Can you just explain a little bit about what a lead-in period is?
Well, when I was in Canada before I moved to Texas, I completed a number of psychiatric drug studies on contract to drug companies, so I know how all this works. So the lead-in period is you're going to be randomly assigned to the new drug, the standard drug, or placebo. But everybody gets assigned to placebo without knowing it for the first week. And that's to see if there's people who just aren't cooperative, they drop out, they don't show up, they develop horrible side effects when they're just on placebo. So that's a way to sort of screen out unsuitable people. So a lead-in period is standard design in all kinds of different studies. The reason for a lead-in period for the enzyme patients was, can they eat? Will they show up? Are they scared off? Can they even swallow that many pills? Will they agree to do the enemas and so on? Because there's no lead-in period, 11 out of 39, almost a third of the people don't even finish 1 week.
So I think that this next point is going to genuinely surprise our listeners. Despite developing the protocol being tested, As you mentioned, Dr. Gonzalez was excluded from screening the patients who were assigned to the nutritional enzyme treatment arm. How was that justified? And what was the practical effect of that?
Well, it was justified by we, the Columbia people, want to remove bias, and the bias will come from Dr. Gonzalez. So we'll just kick him out of any control over patient selection and enrollment. We won't allow the lead-in period, and we won't allow him even to come to meetings to talk about this. But what about the bias of the Columbia people? It was wide open, and it resulted in one person completing the protocol fully.
What they didn't seem to take into account is that in order to effectively test the Gonzalez protocol, you need to actually replicate the way that the Gonzalez protocol is practiced in Dr. Gonzalez's office. So he had an extensive screening process, and not just to figure out if the patient is willing to do the program, but to check and see if they actually have the family support that they need, because this is a heavily compliant program and you have to do at home, that they might have any psychiatric illness. So how can you possibly run a compliance-intensive nutritional protocol on patients who violate the protocol's own entry criteria?
Well, surprise, surprise, the answer is you can't. The whole thing is absolutely ridiculous.
So the paper that was actually published had what's called an intent to treat analysis. Now, that terminology sounds rigorous, and I know it's associated with well-designed trials, but you've argued in your paper that it was used in a way that made the results meaningless. Can you explain why?
Yes, I can. So, as you said, intent to treat analysis is a very standard thing throughout science, throughout medicine. And it just means you include everybody in the report, in the outcome, who you enrolled at the beginning. And in most studies, like, there's some people drop out. Not 90% of people drop out, right? So you follow people along and you report the number of people who finished the study. And you can do two types of analysis. You can do everybody who enrolled at the beginning. That's the intent to treat analysis. Or you could ignore the people who dropped out and you could just look at the people who completed the study. And commonly people will report either or both, but not just the intent to treat. Because the intent to treat analysis destroyed the protocol, made it look completely ineffective. So it's like, how good is the police department at preventing crime? Well, we intended to send police officers out, but we never did. I mean, the whole thing is just, to common sense, ridiculous.
So you've got these 39 patients in the enzyme arm. 30 followed the protocol either not at all, incompletely, or for a very limited period. And then only one patient who adhered fully. So what the paper actually seems to be reporting is the Gonzalez protocol's performance is largely the outcome of patients who weren't actually on the Gonzalez protocol.
Right. So because of the intent to treat analysis, excluding Dr. Gonzalez from having anything to do with management, selection, no lead-in period, all of that, the outcome that's published, and it's also on the National Cancer Institute website, was that the enzyme protocol people had an average survival of 4.3 months, whereas the chemotherapy people had 14 months. And that just gets quoted. Definitive scientific proof that enzymes are useless. But actually, if you look at the literature before that, it's exactly the opposite. So in the 1999 pilot study, Gonzalez and Isaacs, the average survival time was 18 months. And on a big considerably study, the average survival time was 5.6 months. So all of a sudden it flipped because of this bogus intent to treat analysis.
Well, now I want to get to something that I find even more troubling, which is the staging data. So the severity of cancer at the time of the entry into the trial is supposed to be fixed and balanced between the two arms of the trial, right? What did the data show and what happened to it over time?
So this is very, very peculiar. You think some of the other stuff was peculiar. So originally, at the time of enrollment, supposedly there was stage 4 is the worst prognosis, the most severe, spread all over your body form of pancreatic cancer. The chemo people had 38% stage 4, whereas the enzyme people had 76%. So the enzyme, it was not balanced at all. The enzyme people were loaded up with way more severe cases. And that's in the data, that's in the records. It's not just made up. But in the paper, it says there was 60.9% stage 4 in the pancreatic enzyme arm and 68.7% in the chemo arm. So it's pretty well balanced. So I don't know where they pulled those numbers out of, but that just seems like they made it up. I mean, it seems outright lying.
From what I read, it looks like there were some unexplained adjustments made, and they disqualified some of the lower stage chemotherapy patients, and then they reclassified some of the stage 4 enzyme patients to stage 2 and stage 3. So, adjustments were made long after the enrollment closed, and I think that that's very unusual.
I don't know exactly how they did the fiddling, but they clearly changed the staging data long after everybody was admitted to the study and long after the original staging data at the beginning of the study.
And Dr. Ross, can you think of any legitimate scientific reason to reclassify a patient's cancer stage years after they enrolled in a trial?
There's absolutely no plausible, valid medical reason to do that. You don't just change stages months or years after enrollment.
So just to be clear, the paper reports 32 patients in the enzyme arm, but you say that 39 were enrolled and treated under Dr. Gonzalez's protocol. What happened to the other 7, and what was the explanation that was offered?
So again, this is not just an opinion or an impression or an intuition. It's fully documented in the records that 39 people were assigned to the Gonzalez Protocol. 7 of them just disappeared with no explanation, no comment whatsoever. So it's in the paper, it's 32 people. So why? What happened? I have no idea, but you can't just vanish 7 out of 39 people with no explanation.
So there's also an asymmetry in how the two arms were managed during the trial. Chemo patients whose treatment wasn't working could have their protocol adjusted, whereas enzyme patients couldn't. Although in Dr. Gonzalez's private practice, he continuously adjusted his patients' protocols. So why does that fact matter?
Well, that fact matters for several reasons. So it's back to Dr. Gonzalez is completely excluded from study design. His opinion about lead-in is disregarded, and that's to prevent bias. But then we have massive bias coming from the doctors at Columbia, which shows up in many, many different ways. So the doctors at Columbia are allowed to adjust the dosage because that's standard practice. You adjust dosage all the time in all areas of medicine, including treating pancreatic cancer. Standard practice in the Gonzalez protocol to adjust things and increase this, decrease. Person's experiencing nausea, we do this, but no adjustments are allowed at all. It's completely unfair, biased, and so you're not actually testing. There's a whole list of reasons, but this is another reason. You're not actually testing the protocol as it actually operates in reality.
It's so painful to relive all this, Dr. Ross. I met Nick right when he started doing this trial, and I remember him telling me when we were stating that he felt like it was actually safe for him to bring a committed partner into his life because he was finally being acknowledged seriously, and he thought that the worst of his troubles were over. And of course, that's not what happened. So finally, maybe the most jarring detail of all is that Dr. Gonzalez treated every single patient in his study. He was the investigator, and yet he wasn't an author on the paper. He didn't even know the paper was being written. He didn't get to review it before it was submitted, and he only found out it was being published when he saw it online. In your experience in the research world, how unusual is that?
So when you say your experience in the research world, I'm an author on 300 peer-reviewed published papers in the literature, almost all psychiatry. So I've got like a lot of experience and I've talked to a lot of people. This is not just coming out of nowhere. To have a co-investigator, a lead co-investigator, not be an author on a paper is completely unheard of. I'd be surprised if you could find one other example of that in the entire medical literature. It's just absolutely unheard of. So it's extremely rude, it's cruel, it's mean, and it's just not the way academia is supposed to function.
And now, folks, what makes this story different from researchers disagree about a study is that multiple federal agencies investigated this clinical trial and found serious problems. So let's walk through that record, Dr. Ross. And specifically, I'm interested in how, as you know, Dr. Gonzalez requested an investigation by the Office of Human Research Protections. It's called the OHRP. And this is the federal body that oversees patient rights in clinical trials. What specifically did they find?
So they're not like pro-enzyme people. They're like neutral. They don't have any skin in the game. If anything, they're going to be biased in favor of chemotherapy. So they're not going to make some soft analysis just to please alternative medicine people at all, zero. And what they found is that the majority, 42 out of 62 people, were not properly enrolled in the trial. This is the official conclusion of the government of the United States. Published, written. It's not just an opinion.
And I remember when Dr. Gonzalez's office figured this out because they went and requested copies of all the signed patient consent forms and literally went up to Columbia and sat there and asked to make copies of them. And that's when they discovered how many patients had not even been given any informed consent. And this finding is actually posted on the OHRP website, but interestingly enough, it's not mentioned anywhere in that published paper.
Well, none of these flaws that we've been talking about, none of these flaws are just our opinion. I mean, these are objectively established facts. None of them mentioned in the paper.
So then after publication, the FDA also investigated. What were their findings?
The same. Tons of problems with informed consent, study design, keeping records. So the FDA agreed with the OHRP.
And those findings are actually published on the FDA website under Chabot, John A.
Right. So again, this is not just, because this could sound like a whole bunch of sour grapes, right? But it's not. It's just stating the facts.
So as I mentioned earlier, there's also a letter from within the National Institute of Health itself, the NIH. It was written by Dr. Linda Engel, who is the official NIH spokesperson. And that letter acknowledges that the trial was probably producing meaningless data while the study was still running. Well, what does that letter say? And what does it tell us about what the NIH knew and when?
Well, the quote is, this is from Linda Engel, to emphasize official spokesperson for the National Institute of Health. It is very difficult, if not impossible, to ascertain treatment effect with certainty. So it's basically not a meaningful trial. So again, this is the official position of the National Institute of Health. And what do we see? I corresponded with the journal that published the Chabot paper. They refused to do a retraction. And I corresponded with the National Cancer Institute. They refused to change anything on their website, including they say repeatedly on the website that the trophoblast model states that toxins in the environment cause cancer, and the purpose of the enemas is to get rid of the toxins that cause the cancer. Completely false. The protocol and the model don't say anything like that at all. There's not a word in Dr. Gonzalez's writing about toxins in the environment cause cancer. There's not a word about we're getting rid of the toxins through the enemas. It's explained in great detail that we're getting rid of the toxins that come out of the killed cancer cells. It's wrong, and it's demonstrably wrong. And they just refuse to change it.
I want to get back to Linda's letter because there's also this section where she says, there is, in fact, reason to be concerned about this issue and that it clouds the interpretation of the data. And interestingly enough, when the Chabot paper was actually published 5 years later in 2010, there's absolutely no mention of this letter from Linda Engel.
Of course. So people who've been listening this far kind of got the hang of, oh, this is how the whole thing operated. It's like, it's not surprising.
Right. There's a pattern here.
Mm.
So Dr. Gonzalez actually contacted several people in Congress when he was going through this situation. And specifically, he worked with Congressman Dan Burton. And the congressman actually used some of his very final words in the congressional record before he retired to address this specific study. What does congressional attention to a clinical trial actually mean, and how unusual is that?
Well, I don't know exactly what's in the congressional record, but that's highly unusual that Congress actually pays attention to officially and puts in the record any comment on an individual scientific paper. It's highly unusual.
So that Chabot paper was published in 2010, and it's now cited regularly by oncologists to counsel patients away from being on the Gonzalez Protocol. And in fact, as we've discussed, the NCI still references it on their cancer.gov site. And given everything that you've described here, the OHRP findings, the FDA findings, the NIH's own letter, why do you think that the scientific record hasn't been corrected?
Well, obviously, I don't know for a fact for sure, but there's only one possible conclusion. There's no political will to correct all these problems, and there's a massive political will to keep a lid on the effectiveness of the protocol.
Is there actually a mechanism that exists for a paper to be retracted or corrected based on federal oversight agencies?
All medical journals have a retraction mechanism. It's basically somebody or some group of people communicates with the journal, says, here's all the reasons we think this study should be retracted. And not frequently, but intermittently, regularly, papers get retracted by journals. It happens regularly.
So at this point, I'd like to shift from what went wrong to what could go right, because you haven't just documented the failures of this trial. You've actually published a detailed roadmap for how the trophoblast model of cancer should be researched going forward. You've laid out a 6-step research program starting with basic science and building towards human trials. The first step involves something called protease-activated receptors. Could you just explain in accessible terms what those are and why they're a promising starting point?
So there's three types of pancreatic enzymes. Some for lipids, for fats, some for proteins, and it seems to be that trypsin is the active one in the protocol. But it's probably all three. Amylase is the third category. So what does trypsin do? In the normal digestion cycle, you eat a meal, proteins go into your stomach, they go into your top part of your small intestine, and trypsin cuts them sort of, not exactly in half, but cuts them in half so they can be absorbed into your bloodstream, so then they can be used by your body. So trypsin is a protein chopper. And on the surface of cells, there's receptors for everything that cells do. There's receptors. And one group is called G protein coupled receptors. And a subtype of G protein coupled receptors. So everybody's going, oh my God, I'm getting a headache. But the point here is this is obviously technical and real science. And it's outside the protocol. There's labs all over the world studying all this kind of stuff and publishing in mainstream journals. So a subset is called protease activated receptors. And there's PAR, protease activated receptor. There's PAR1, PAR2, PAR3, PAR4. And PAR2 and 4 are the ones that trypsin interacts with. So there's a receptor sticking out of the cell, and it's this long. And this particular enzyme comes along and chops the top off the receptor. And that causes the receptor to change shape all the way down into the inside of the cell where the other end is. And then that, in turn, activates signals inside the cell. So this is all totally worked out scientifically. And so that research has basically already been done. We know what trypsin does. And no doubt it does the same on the wayward trophoblasts, the cancer cells. So step one's done. Step 2 out of 6 also has been done all around the world, partly. So, okay, you change the protein that's sticking out of the cell. Something happens inside the cell. What are the signals? What are the steps? And as everybody knows, it activates clathrin, dynamin, and beta-arrestin. I don't even know what those are exactly, but the point being here, this is hardcore science, and some of the signaling steps inside the cell are all worked out already. And then the remaining steps are, okay, what do those things do inside the cell? They've got to get over to the DNA, and they've got to turn DNA on, off, up, down, change the proteins that the DNA is in control of. So this is the core basic science of how does this all work, hardcore scientifically. And so we're like 1 1/4 steps along that pathway. We, the scientific field in general. Then step 3 is identify the genes that are activated by the receptors. What do they do? And then once we've got that figured out, step 4 is going to be, this is step 4 according to me, what we want to do is we want to get different types of cancer cells, put them in a little dish with nutrients so they grow and grow and grow and replicate and get more and more and more of them. And then we want to have some normal trophoblast cells and some just white blood cells, some kind of control cells. And we want to sprinkle in different amounts of pancreatic enzymes to see what happens. And I predict, which is totally testable scientific hypothesis, I predict that if you dump in 100 pounds of enzymes, it's just going to kill everything from toxicity. But you'll find there's a dosage range where it's not toxic to normal regular cells, but it switches cancer cells into stable non-cancer cells. So we can figure out what are the dosages. Are there different dosages for different forms of cancer? Are there some cancers that don't respond at all? All can be studied. And there's some of that going on in the world already in mainstream labs. Then step 5, there's already been done a little bit, but we need a lot more of step 5. Step 5 is animal studies. And this is for any drug, for any purpose. It goes through these steps. So Dr. Gonzalez has published, crammed in one paper, 2 different studies of mice where they're given, basically they have carcinogen painted onto their skin so they all get cancer, or they're given cancer internally. And the normal, regular, untreated control mice, after 35 days, 38% were still alive. The ones who were given the pancreatic enzymes, 79% are alive. So it doubles the survival rate. 35 days is a long time for a mouse, right? Because they don't live that long. So there's actually animal studies, and we need more, showing double the length of survival. And it may be that the dosage was not exactly the right dosage. It would have had even better survival if the dosage was higher. So there's a lot more work needed to be done there. And then step 6 is the human trials. Supposedly we've got one, which is the Chabot trial, but I rate that as 0. So we don't have a valid, real, well-designed, proper human trial. But that's where we need to get to. And this is just the way it goes for all drugs, all treatments in medicine.
That was incredibly helpful for you to explain, Dr. Ross. So if a properly designed phase 3 trial were to be run today, what would it need to look like to actually test the Gonzalez protocol, as opposed to what the Chabot trial did?
Well, properly designed trial structure and rules are well known in science. So this is not just making it up out of nowhere. You need the people who are involved in the treatment actually involved in meetings, discussion, and planning. What's the protocol like? How's it set up? What are the rules? What are the screening requirements? What's the lead-in? All of these different aspects of any properly designed study. It's not mysterious. It's not complicated. All doctors know this stuff.
All right. So I want to come back to earth here, because many of the people listening to this show right now are facing a cancer diagnosis, or they're sitting next to somebody who is. And so this is not at all abstract for them. When somebody hears that the NCI studied the protocol and it failed, and they're deciding whether to explore it, what do you want them to understand about that study, what it actually showed and what it didn't show?
Well, as we've been discussing, it basically showed nothing. It was not a valid study. You can't reach any scientific conclusion from that published paper and what it says on the NCI website and so on. So in a way, it requires a leap of faith to sign up for the Gonzalez Protocol, which is true if you decide on chemotherapy. Chemotherapy doesn't save everybody and has horrible side effects. There's a leap of faith required to sign on. But there is, as we've been discussing, lots and lots and lots and lots and lots of published cases where people have done amazingly well. And not just done well, but they haven't had all the horrible side effects of chemotherapy. They've actually felt pretty good within 3 months of starting the protocol and are alive a decade plus later. It's not just sit back and take a pill every morning. I mean, it requires commitment, work. But if you want a chance to live another 20 years when you got stage 4 pancreatic cancer, this is what you should do.
So, Dr. Ross, the remarkable cases that you have actually documented, people with stage 4 pancreatic cancer alive 10, 15, 20 years later, those outcomes are almost unheard of in conventional oncology. So how should a patient or a family member weigh that evidence when talking to their oncologist?
So this is a complicated, difficult problem because many oncologists are just going to have closed minds. It's all nonsense. The paper that was published by the revered people at Columbia shows it doesn't work. And then you're not going to be able to engage your oncologist in a 1 hour discussion. They don't have time for it. So there's several paths to follow from there. One is, okay, you just go get conventional chemotherapy and forget the protocol. The other is you forget your oncologist, don't talk to him anymore, go do the protocol. And then the best option would be stay with your oncologist, let him know you're doing the protocol. He says, well, I believe in it, I don't believe in it, but it's your life. And he continues to follow you for the remaining 3 months of your life. And then he goes, wait a minute, you're still alive 5 years later? So that would be the best. But I don't know what percentage of oncologists would continue to see somebody when they're not cooperating with treatment. So it's a bad problem that I don't have a solution for.
Well, for anyone who wants to actually learn about the Gonzalez Protocol and explore it to see whether it's right for them, we, and you included as a member of the board of the Nicholas Gonzalez Foundation, have an awful lot of information on our website, which is thegonzalezprotocol.com, including information about how to actually apply to work with one of the doctors that we have educated in this protocol, who are actively treating patients around the world and getting similar results to the results that Dr. Gonzalez got. So we would like and encourage patients to use our website as a resource and ask us the questions and then ask us how we can help them. Do you have anything more that you'd like to add to that?
Well, I think it's worthwhile to point out that Mary Beth and I, our combined income lifetime from the Gonzalez Protocol, zero. Like we're not making any money off of this. This is because, for me personally, I think the evidence is overwhelming. Why would you not want to try when regular oncology is saying you've got stage 4 pancreatic cancer, you've got months to live, not even worthwhile bothering with chemotherapy, or maybe give you chemotherapy and you'll live an extra couple of months while feeling horrible the whole time. Why would you not want to give this a try? I would. I remember when I read Suzanne Summers' book, whatever it was, 4 or 10 years ago. Knockout, yeah. So it must have been, it was more than 10 years ago when I read that book. So I read that book before I met Nick. And I just remember going, oh, if I ever get pancreatic cancer, I'm going to go see that guy. That was my conclusion. And then I forgot his name and I had to look in the book. And then my friend handed me the Gonzalez book and off I went.
Well, Dr. Ross, I just have one last question for you. You are a psychiatrist. You've spent years on research that the mainstream tends to dismiss or ignore. What motivates you and keeps you at it?
That's a good question. Just because I'm hard to beat down is number one. And in psychiatry, it's the same thing with the protocol. I just find it very intellectually interesting. How do people's minds operate? What are their defenses? How does trauma tie in there? So it's just an intellectually interesting puzzle. Same with how does the Gonzalez protocol work? So there's just a pure intellectual part of it. And then there's the uncooperative, rebellious, Colin Ross aspect to it. So in the psychiatry, in the DSM-5, there's a diagnosis called oppositional defiant disorder. And I like to brag that I have oppositional defiant disorder towards psychiatry. Which is a joke, but I've written many thousands and thousands and tens of thousands of words about here's what's going on in psychiatry, which I'm critical of. And then it's just when in my own, so I don't treat cancer, but in psychiatry, using the treatment model that I developed, just people make the most amazing recoveries. Compared to grumbling along and in and out of hospitals for the next 30 years. So it's the joy of seeing the amazing healing. It's the intellectual complex puzzle part of it. And then there's just the, I'm not buying what the mainstream says, rebellion quality of it.
Dr. Ross, thank you so much. This has been one of the most important conversations I've had on this show, and I think one of the most important ones for our listeners to hear. So for everyone listening, the papers Dr. Ross has published on this specific topic are available in peer-reviewed journals, and I'll link to all of them in the show notes, along with the NIH letter, the FDA findings, and Congressman Burton's statement that was in the congressional record. Dr. Gonzalez wrote a book called What Went Wrong. It's right behind me. And it tells this story in full from his own perspective. If you want to explore the Gonzalez Protocol itself, the Nicholas Gonzalez Foundation is at thegonzalezprotocol.com. And we will be back next week. Thank you for listening to Your Way Back.